Hello everyone, welcome to your lesson on multiplying binomials. So in grade 9, you learned about distributive property where you had one term outside the bracket and you multiplied it in. But now we're going to look at what happens when both of your brackets are binomials. And the method we use is called FOIL, and it just stands for first, you multiply your first terms in both of your brackets, you multiply the outers or the outside terms, then you multiply the insides, so the B and the C, and then you multiply the last terms. But pretty much the basis is you multiply each term in the first bracket by each term in the second bracket. So it's this little rainbow. So from A, you go to both terms inside the second bracket, and from B, you go to both terms inside the second bracket as well. So let's actually give that a try with the first example. So first I'm going to distribute the 3x into the x plus 4. And when I do that, 3x times x is 3x squared. And then 3x times 4 is 12x. Now remember, when you're multiplying terms, you multiply the coefficients, and then for your variables, you're going to modify the exponent if needed. Okay, and now I'm going to distribute the negative 2 into my second bracket. Be careful with the negatives. So negative 2 times x is negative 2x, and negative 2 times 4 is negative 8. Your final step is going to be to collect your like terms, which is usually going to be the middle terms. And your final answer is going to be 3x squared plus 10x minus 8. Make sure you're writing it in proper form, the x squared term first, then the x, then the constant. Now, if you look at the next one, x minus 3 squared. A lot of people have a tendency to write this as x squared minus 9 squared. They just distribute the 2 in. That is not correct, because we know exponents mean you're multiplying the base by itself. In this case, our base is x minus 3, and we're multiplying it 2 times. So now I can distribute. Okay, so I'm going to distribute that x in to the first bracket. X times x is x squared. X times negative 3 is negative 3x. Now I distribute the negative 3 into my second bracket as well, and I get negative 3x. And be careful here, negative 3 times negative 3 is positive 9. And now again, I collect my like terms, and I am careful with the sign in front of each coefficient, because here I have negative 3x minus 3x, which is negative 6x plus 9. Now notice how this is not the same as the x squared minus 9, which a lot of people would have a tendency to do. So please do not make this mistake. Okay, I want you to pause the video right now and try the next 2 examples on your own here, and then when you are done, turn the video back on and you can take it up. Okay, so hopefully this is what you got. So for the first one, you should have had 6x squared minus x minus 2 once you simplified it. And for the next one, the x plus 5 should have been rewritten as x plus 5 times x plus 5, so that you get a final answer of x squared plus 10x plus 25. Now if you made a mistake, figure it out, find it. Maybe it's a little sign change, maybe you made a silly mistake when you're multiplying it. So figure out what your mistake is and make sure you don't make that again. Make a note for yourself, highlight it or star it, or anything you have to do so that you don't make this mistake in the future. So the previous day, we looked at the 3 different forms of quadratic relations: standard, factored, and vertex, and each one gave us different key pieces of information about our parabola. Now we're going to learn how to go from factored form and vertex form to standard form using FOIL. So all 3 of these equations represent the same thing, but we can pick different information out. So for factored form from previous class, we know that the zeros are going to be 1 and negative 3. But maybe I also want to know the y-intercept. So in that case, I would expand this expression. Now I have negative 2 times x minus 1 times x plus 3. I'm going to deal with that negative 2 at the very end. And that's just to avoid some mistakes. So I apply the FOIL first. So when I do that, I keep the negative 2 on the outside, and I open up a bracket. X times x is x squared. X times 3 is 3x. Negative 1 times x is negative x, and negative 1 times 3 is negative 3. Now in this format, I like to collect my like terms first, and then distribute the negative 2, but you're more than welcome to distribute the negative 2 right away and then collect your like terms. So I simplified 3x minus x to 2x. And now we're back to grade 9 concept where we distribute that negative 2 in, and we're careful with the negative value. So that I have negative 2x squared minus 4x plus 6. And now I can tell that my y-intercept is at 6. Okay. What about vertex form? Right now, from vertex form, we can get our vertex, which is negative 1, 8. We can turn this into standard form as well, but we have to remember when you see that exponent of 2 above a bracket, rewrite it as 2 brackets so that you don't make silly mistakes. And just like before, I'm going to apply the FOIL first, and then I'll deal with that negative 2 afterwards. So I have x squared plus x plus 1, and the plus 8 at the end. The plus 8 isn't affected because it wasn't inside the brackets. And in this case, because I know I'm going to have to simplify and collect like terms with that 8 later, I like to apply my distributive property before I simplify that big bracket. It obviously doesn't make a difference though. So I have negative 2x squared minus 2x, don't do that mistake, minus 2x minus 2 plus 8. And now I can see I have to collect these like terms and these like terms. So your final answer is going to be negative 2x squared minus 4x plus 6, and there's that y-intercept again. Okay, so now we know how to go from factored in vertex form to standard form. I want you to pause the video right here and try C and D on your own before you replay and check your answers. Okay, so here are the answers. So for C, you should have had 10x squared minus x minus 2. Again, careful with those negatives so you don't accidentally put 9x or negative 9x or anything like that. And for D, you should have expanded that x plus 2 squared into 2 brackets and then applied FOIL, so that your final answer is y equals negative 3x squared minus 12x minus 16. And again, just check for silly mistakes. Make sure you're foiling properly. Make sure you're careful with your signs and collecting your like terms. And that's it for FOIL. Okay, so let's look at the last type of example we have, which is when you have multiple brackets, a longer expression. And we're going to follow BEDMAS. So the first thing we're going to do is the multiplication, which means we have to multiply our brackets. I do want to draw your attention to the fact that in front of that first bracket, there is a negative 1 in front, not just a negative, which means you are going to have to distribute the negative 1 in later on. But for now, let's apply FOIL to the first set of brackets. So I have x times 3 is 3x. X times negative 2x is negative 2x squared. Negative 1 times 3 is negative 3, and negative 1 times negative 2x is positive 2x. Notice here the terms weren't in the same order, so it looks a little different when you actually expand, but that's okay. Then I'm going to write minus. Now I have to open up a bracket because I have to distribute this negative 1 in later on. For now, I'm going to apply FOIL, and that's going to stay inside of our bracket. So 3x times 2x is 6x squared. 3x times negative 1, negative 3x. 1 times 2x is 2x, and 1 times negative 1 is negative 1. Okay? And now, I'm going to take the negative 1 that's out here, and I'm going to distribute it into everything. Okay? Sometimes that coefficient could have been a plus 2 that you could distribute. So you just have to be really careful to keep those brackets in place until you distribute that coefficient in. For the first set of brackets, we had no issue because there was nothing in front of x minus 1. So now I have 3x minus 2x squared minus 3 plus 2x minus 6x squared plus 3x minus 2x plus 1. Being careful that all of our signs are changing because we are multiplying that negative 1 in. And now we can collect our like terms. So for my x squared terms, I have a negative 2 and a negative 6, which becomes negative 8x squared. and then I have a 3x, a 2x, a 3x, and a negative 2x, which gives me 6x in total. And then for my constants, a negative 3 and a positive 1, which takes me to minus 2. Okay, just really be careful with your signs here so that you don't make a silly mistake later on, because that would be unfortunate. Okay, I want you to pause the video right here, and I want you to try that bottom one on your own. Be careful with that bracket that's raised to the power of 2. You know what you have to do first. Okay, so here's what you should have for the last example. So I changed the 2x plus 3 squared into 2 brackets, and while I did that in the same step, I also applied FOIL to the second set of brackets just to save myself some time, so that I got the following. Okay, and then from that next step, I distributed the 2 binomials, and I distributed the negative 1 in front into my bracket, and that changed all of my signs. As you can see, the 3x squared became negative, the negative 6x became positive, and so on. And then from there, you're just collecting your like terms. Okay, so find your mistake if you had one. If you didn't, that is excellent, because these are more challenging than the ones we did on the previous 2 pages.